focusing today on seedbank management and then different physical weed control strategies. This is mainly for small scale vegetable farmers. So like Margaret said, my background is in organic vegetable work and also some organic row crop work. So corn, soybean, wheat, and also a little bit of background in science policy and advocacy work. So I'll be going first, and then there'll be time for questions, and then Jordan will be going after me, and then he will have time for questions after that as well. So just to give you briefly a background what ag looks like in Maine, I think it's the work that we're doing can be applicable to your farms in California, as well as we also have a growing and bustling organic agriculture sector. Not as big as California's, but it's getting pretty big. We have a lot of young and beginning farmers. We currently have about 500 organic farms on 55,000 acres, and we're currently the 10th state for our organic crop sales. So the work that we're doing in the organic sector is definitely applicable to a lot of the small scale farms that you have in your state. So a lot of our farms operate one of two ways usually. They're either small enough scale where they're using hand tools on the left, sometimes walk behind tractors, and then larger scale organic is using tractor mounted cultivation tools. I can't see all the participants, but how many of you are operating mainly with hand tools? You can use the raise hand function or put it into the chat. Awesome. That's a good amount. Awesome. And then how many of you are using tractor mounted or walk behind systems? Okay, good. So it's a good mix, which is good to see, because we're doing work in both of these areas. So a lot of organic farms in Maine are on the smaller side, usually less than 5 acres. So they're using mainly hand. But there is increasing interest in using these tractor mounted cultivation tools, which is part of the research we'll be talking about today. So a lot of our farmers usually don't have any issues controlling these weeds that are right here between the crop rows or this inter-row zone. It's pretty easy to come in with a tractor or even a hand tool like a wheel hoe and kill these weeds between your crop, because you can just go right between them and not worry about the crop. But this might look like a familiar sight. So it's difficult to get these weeds that are growing right in the crop row or the intra-row area. If you get your tools too close to the crop row, this is definitely for like tractor mounted tools, but hand tools also. It can be easy to have high levels of crop injury or take crop plants because you don't want to get too close to your crop. But then you end up with this strip of weeds right around the crop row. And as you can imagine, these weeds are the ones that are competing the most with the crop for the water and the soil fertility. So this is still a really big issue for a lot of organic farms. So the first part of the research I'm going to talk about today is what we call tool stacking. This is the idea that you're going to use more than one tool at the same time. This can help reduce the number of weed seedlings that survive your weed control efforts. This also reduces seed rain. If you're reducing the number of seedlings, you're also going to reduce the number of weeds that are reaching maturity and producing seeds. The other thing we'll be talking about today is seed bank management. So what if we could use these different practices early in the season that's going to reduce the number of seedlings that are even present when we go and cultivate, because that will reduce the amount of hours you spend hand weeding. This also reduces seed rain. And then when you combine the two together, you can start to see reductions in the number of seeds that you have in your seed bank. So some of the seed bank management work that we've been doing on the left is, let's see, too far, 6mm black silage tarps. It's pretty cold here in the spring, so we usually can't put these down for till May usually, or about 5 to 7 weeks before we want to plant our crop. I'm sure this is going to be much different somewhere where it's warmer and drier. But the idea behind these tarps is that you want to do some seed bed prep. You want to go out and harrow your field and stimulate the weeds to germinate. When you put the tarp down, those weeds, they've got that germination cue, they germinate, but then when they're under the black plastic, they are not able to receive that photosynthetically active light that they need to actually grow. So then they just die under the tarp. We've found this to be extremely effective in that for that 5 to 7 weeks before we plant our crop. So we harrow our field, we put the tarps down. Once we take them off, we do our final seed bed prep before planting. Then we come in and we flame weed, the picture on the right. So this is getting all those weeds that germinated after we took the tarps off and after planting, and when we actually are able to come in and do our cultivating or hand weeding or whatnot. So we want to reduce the number of weeds that we have growing directly with the really small young crop that is just germinated. And this can be used for many different kinds of crops. We've used this in corn. We've used this in carrots and beets as well, aiming for about 1 day before the crop actually comes up. So what we did is we went in and measured weed densities 14 days after we planted our crop. So where we applied these tarps and then we did our flame weeding as well, we reduced the number of weeds in that crop row by 4 times. So we had less than 20 weeds in a square meter. And I'll show you pictures next. That's visually what that. We then recorded how long it took us to hand weed 14 days after planting. If you have really small crops like carrots or beets or onions, when they're really small, you want to risk cultivating when they're very small because you're going to have high levels of mortality. So usually there's some sort of initial hand weeding that has to be done before you can get into the field and do more intensive cultivating. So when we applied the tarps and then did our flame weeding, we reduced how long it took us to hand weed by 50%. This was reduced to 100 hours per acre. And a lot of farms are spending at least 200 to 300 hours per acre on hand weeding labor, at least here in this area. So these are some soil samples from our different research plots. On the left is where we did not use our tarping and flame weeding. And on the right is where we did do the tarping and the flame weeding. So these are soil samples that we took and put in flats in the greenhouse and grew them, and then we looked at which weed seedlings came up. So visually, this is just very striking. You can see like just how much we reduced that early season weed emergence. So would you rather go out and hand weed what's on the left or what's on the right? So this can really help reduce the amount of labor you're going to spend when your crop is actually in the ground, it's emerged, and you need to do some sort of initial hand weeding event. So this picture shows what these research plots looked like right after we pulled those tarps off. So the left side, there were no tarps applied, and on the right, we did apply a tarp. And you can see that that's pretty bare soil. And there's quite a few weeds. You'll need to kill those weeds before when you're doing your final seed bed prep, before you plant your crop. And what I want to point out is the size of these weeds. They're not small cotyledon or one true leaf stage weeds. They're pretty large. So if you're trying to do your seed bed prep before you plant and you're trying to kill those weeds of that size versus much smaller, tinier ones, there's more of a chance of those weeds that are in that circle, those large weeds, there's a much greater chance of them rerooting and not being killed by cultivation and your seed bed prep. And then you're going to have these large weeds already competing with your crop when it's really small.
Rebecca, you have a few hands up with questions, I believe. I'll let you decide if you want to take them now or wait. Or
I think those are still up from when I asked about the tools, but I do want to do questions at the end.
Okay, thank you.
Thanks for pointing that out. So that's the Seedbank management. So this idea of cultivation tool stacking. My advisor, Dr. Gallandt, and a former student of his found that when you stacked cultivation tools together on your cultivating unit, so here we've got the zoom window. Okay, you got portion weeders, finger weeders, and tine harrows. So this stacking means that you're going to use more than one tool either at a time, like in this picture, or you're going to come back into your field and do a subsequent pass with a different kind of tool. So maybe you used just finger weeders in that first pass, and then you went and set up tine harrows, and you came into a second pass with those. It's typical for people to use just one kind of tool, but the average efficacy, or like the number of weeds that you kill, is pretty low and also very variable. So a lot of work has shown that when you're using just one cultivation tool, you're only going to kill about 50% of the weeds that are in the field. But the variability is very high. And they found that when you used 2 tools and also 3, you can not only increase your efficacy, you can also reduce that variability. So you can kill more weeds and you can kill them more weeds more consistently. So that's been some pretty promising work that's been going on the past few years. So we looked, the past 3 years, we've looked at some different cultivation tools. We've looked at finger weeders and these hoe ridgers. So if you're familiar with hilling discs, these act very similarly to hilling discs. So as they drag through the soil, they push the soil up into a ridge around the crop, as something like this. So we looked at what happens when we use just these finger weeders by themselves. How many weeds do we kill? And then when we come back in and use the hoe ridgers after the finger weeders, how many weeds can we kill then? And I also point out in this picture, these tools are meant to target in the crop row because that's where we have the most issues trying to control weeds, is the ones that are growing directly around the crop. So that's what these tools are designed to do. You'll notice that we also have some tine harrows here that are set further apart. Those were to kill the weeds between the crop rows so that it was consistent across all of our different research treatments. And then in front of our hoe ridgers, we have these European sweeps. So these are meant to just travel in front of your tool and break any sort of soil crust that might be happening, which can help make the soil a little fluffier and increase how well these tools work. So we found that tool stacking, so using our finger weeders and then coming back into the field and using our ridgers, gave us more than 85% weed control. We tested this in over 3 years in 3 different organic vegetable crops, sweet corn, bush bean, and table beet. And even though we have crops here that represent large seeded crop with the corn and then a very small seeded crop with the beet. When we used both of these tools and did this tool stacking, we did not see an increase in crop mortality, which is great news because that's a potential trade-off of these tools, is that yes, you're killing more weeds, but you could potentially kill more of the crop. We did have these set intentionally to more of an intermediate setting. So not spaced too far apart, but not spaced so close together that they're just wiping out the crop, because nobody would really want to cultivate like that anyway. So I will point out that these were kind of set at a more intermediate spacing so that they could still kill a lot of weeds, but not harm the crop as much. So this led us to our next research question. We know that the tool stacking with tractor mounted cultivation tools works really well. I mean, high levels of weed control. But could this also be applied to hand tools? Because a lot of the farmers we work with are using hand tools. So we partnered with Johnny's Selected Seeds, and we're using the Terra double wheel hoe. So the Terra is a company out of France, and they do sell their products through Johnny's Selected Seeds. So if you think of the traditional wheel hoe that's got the blade on the bottom and you run it between your crop rows, this takes that wheel hoe design, but attaches some toolbars onto it right here. So you can purchase different toolbars, and then you can purchase different tools. So you see they got these discs with little beet knives, some finger weeders, a harrow. So these are tools that are typically only available to purchase for a tractor mounted cultivating unit. So Terra has said, well, what if we just make these available to small scale farmers? They're smaller, they're very easy to adjust. It's much more cost affordable than a tractor mounted cultivation tool. And they made the option, you'll see here, to attach 2 toolbars. So you can use more than one tool at a time. So it's taking this idea of the tool stacking that we were doing with the tractor mounted tools and doing it at a scale that's much more applicable for small scale farmers. It's also pretty easy to maneuver as well. So throwing some prices up there for anybody that's curious, and I can also put the Johnny Selected Seeds link into the chat when I'm done. So the wheel hoe itself, the unit costs $465. And then if you want to purchase the tools to attach to it, like these, they run about $100 to $250 for the set. So you would receive both of these tools and then the clamps that secure them onto the toolbar. So my experience with this has been in bush bean and table beet. We've only done a couple years of research on this, but I'm very impressed with it. I like it a lot. This is not an endorsement of any kinds of this company, but speaking from my experience over the past 2 years with this tool, it's very comfortable to use. It's very easy to maneuver on a bed system with even 2 or 3 rows. We did work with a farmer who used this in onions that he had 3 rows on a bed. So you're able to either straddle the row or hang on to the handle kind of offset and walk next to the bed. So you can see here, there's a toolbar in the front where you can use just one tool, and then you can attach a second one to the back. So this allows you to adjust your tools in or out. These toolbars are super easy. There's just a little clamp right here that you unscrew, you move the tools in or out wherever you want, and then you just tighten them back into place. The tires are just like bicycle tires. You can just pump air into them. So it's easy to take care of, it's easy to use, and it allows you to use more than one cultivation tool. So we looked at, well, what does this do for crop mortality and weed control? So we found that a very similar pattern to the tractor mounted tool stacking work. When you used one tool, you had pretty low weed control, about 35 to 40%. But when you stacked tools together, we increased our weed control. And it did not take much time at all to set up a different tool, add a second or third tool, or anything. And then we also found that it did not increase our bean mortality, and it also did not affect our bean yield, which is great. We did find that it did increase our beet mortality a little bit and lowered yield, but it's just a matter of setting the tool to where you're comfortable using it. We did not have very good beet stands because we had a very hot summer. But if you plan to maybe overseed a crop like that, like carrots or beets, and seed at a higher rate, knowing that you might take out some of the crop, then this is still pretty applicable to use.
So my name is Jordan Parks, and thank you, Margaret, for that introduction. So what I study is physical weed control tool settings, and basically my research focuses on how to better set up tools to optimize farmers' weed control. There we go. So outline of today's talk, I'm going to go over some problems in physical weed control, and then I'll talk more about my research using a soil bin and my evaluation of finger weeders, and then we'll move on to questions. So the problem in physical weed control is that the weed mortality is low and highly variable. It's like compared to most herbicides, which are 90 to 100% effective with weeds. And so here's a graph, a histogram of a study done with a Danish S-tine tool. And this was a study measuring from the intra and inter-row zone, which Rebecca talked about in her talk. And this was in a field of corn, and you can see basically the variability goes all the way from killing none of the weeds to 100% of the weeds. And so basically we need to break down physical weed control to better understand it. So here I've broken it up into 4 complex models, and at the center we have efficacy and selectivity. And these are what we measure. And so efficacy is basically the proportion of weeds killed by the tool. So we'll go out in the field and count weeds in a specific area, and then run our treatment with the tools over it, and then go back out and count those, count what was left, and that is considered our efficacy. Selectivity is a ratio of weed damage over crop damage. And so what we're looking for in tools is high selectivity, which would mean high mortality to weeds, but low crop damage. So in this model, my research focuses on this tool aspect right here. And so firstly, we built this bin called a soil bin in a heated glass house. And this design is based off of a research group in Canada. And we built this to better evaluate tool settings by eliminating basically environmental variability that we find in the field. And so this bin is 12 meters long by 1.6 meters wide. And within the bin, we have a landscaping fabric with a layer of coarse gravel, and then we have a sand layer that is a sand mix that is 10 centimeters thick. And we chose to use sand because it's a lot easier to manipulate while doing a lot of tool studies. So here's a picture of the sample area. And here's after a cultivation event, we have a leveling attachment that we put on there, which levels the soil. And then we have a weighted rolling compactor, which firms up the soil. And this resets our soil back to a standard condition. Here's a picture of the tool carriage system. And here's where we actually mount the tools. And here we can adjust the angle as well as the depth. And in this picture right now, we have a tine rake from Johnny Selected Seeds. And Rebecca talked about them. They're just a company here in Maine that sell seeds and small farm equipment. And I used this rake to develop methods for testing physical weed control tools in a bin, because little research has really been done in soil bins with this work. And so what I also use in the bin is artificial weeds. And so what we use are just 35 millimeter long wooden golf tees, and we plant them to a depth of 33 millimeters. And in the bottom left, you can see is a scoring system that we developed to basically score the disturbance and make that into an efficacy value. So 1 through 3 are considered dead, and 4 and 5 are considered alive. And so using this tine rake and this artificial weeds, we developed methods to a point where I could run an experiment with the tine rake in the bin. And so next, what we did was compare this study to previous field studies that were done in the field. And so what you're looking at here is a box and whisker plot. And basically we use these to measure, to look at the variability within our experiments. And on your whiskers, you have your minimum value, maximum value, and this line right here is your median. And so that's just if you rearranged your data in ascending order, that middle value, that would be your median. And then these are broken up into what we call quartiles, and that basically separates your data into groups. So we have efficacy here as our dependent variable, and down below we have some field studies, and these were previously done with the same tine rake at the same speed and the same angle. And this is efficacy data from real weeds. So we had a wild type and some surrogate weeds. And here's my study here with artificial weeds. And so statistically, I can't compare these because the field studies weren't specifically made for to cater to the soil bin study. But this is basically a way to look at it observationally to see, you know, if we're on the right track or if we're onto something with using these artificial weeds. And so this year I'll be comparing soil bin experiments specifically catered to ones I designed in the field, so then I can statistically compare those. So switching gears, here's talk about some of my field studies. My first one was with the hawk finger weeders, and I tested 3 different angles and 3 different spacings, and I had a hand weeded control. And this was in a crop of red table beets. So here's an example of a positive angle on a finger weeder. So this would be angled away from the operator. And you can see it kind of does the scrubbing motion where it makes these V's right here. at this angle. And so a negative angle would be angling it towards the operator. And what this does is basically the fingers kind of act like bulldozers, and they grab soil from the side and then throw it into the crop zone where we call the intra-row zone. So here's the results from my study. So we have intra-row zone efficacy as my dependent variable. And down below, we have my treatments. And so first we have the control, and that was just a hand-weeded control, weeding everything completely from the plot. And then the first symbol in these are the angle of the finger weeder. So negative would be the maximum negative angle that you could run finger weeders. And then we have a 90-degree angle, which a lot of finger weeders are operated at. And we have our positive angle, which is angled away from you. And then next, after the backslash, we have a negative spacing, so that I had a 1/4 inch overlap of my fingers. And then a 0 spacing is when my fingers were touching each other. And then I ran positive, which would be 1 inch apart from each other. And so on these bars, we have these lines right here, and that's our standard error. And this tells us basically how far our sample mean is from our population mean. And then above that, we have our mean comparison, which are all these letters here. And so basically any of these bars that are sharing any letters are not statistically different from each other. So all of these, from all the ones that include A right here, these are all statistically the same from each other. But if you were to compare this one, the A, with any of these down here below, they are vastly different from each other. And so the takeaway from this graph is that basically what I found was that having a negative or 90-degree angle on your finger weeder basically resulted in high efficacy compared to a positive angle, even with all of these different spacings here. And so I will replicate this study again this year to see if I get the same results, but it's pretty exciting. And so next I did a speed experiment with the same finger weeders. And so I ran them at a 2, 4, and 5 mile-an-hour speed. And then I also had a hand-weeded control. And this was in a crop of bush beans. And so here we have my results, and efficacy is intra and inter-row combined. And down below, I have all of our speeds. And so basically what I found was you could see that all of these are the same, have the same letter, and are all statistically the same. And so basically what I found was it's really good news for finger weeders, because basically if you're running a hand tool compared to a tractor speed, you're still going to get the same efficacy no matter how fast or slow you're going. You know, if you're training somebody on a tractor and they're kind of slow in the beginning, you know, you're still going to get the same efficacy as, you know, a 30-foot wide cultivator with camera guidance system. So this is exciting. Well, once I repeat this, we'll see if I get the same results, but that kind of gives some robustness to these finger weeders.